joining us from Australia and has previously worked at HashiCorp, which makes him the ideal person to talk about infrastructure as code. Take us away, Dan.
Thanks, George. Thanks, everyone. My name's Dan. I'm super excited to be with you here today. I realize I'm the last talk in the engineering track. I hope you've had a lot of fun. I hope you've learned something. I hope you've met some people. I hope you're looking forward to the drinks and networking later. I certainly am. Today, I'm going to be talking about infrastructure as code, as George mentioned. I'm going to describe a little bit just what that is, kind of my point of view on that. We're going to talk about a few examples of teleport in a highly automated, dynamic environment. And I'm going to show you some of the code behind those examples as well. So let's get into it. I don't think I need to explain teleport to you. I probably also don't need to explain infrastructure as code to this audience too much, but I do just want to level set, and I do like to start with an analogy. Here we have a plan for a house. Hopefully everyone here has been involved in some kind of project that involves building something or maybe renovating something. If I have a plan or a blueprint, in that plan I can describe what rooms I would like, the size of those rooms, even what might be in those rooms, right? This represents my desired state for a particular project. And typically, if I was in a building project, I would then hand this off to a builder or a contractor who would interpret that plan and handcraft something that hopefully I like. In the world of infrastructure as code, you can think of the plan as your code. However, we're not going to hand this off to a person to manually craft something. That is the old way of doing things. We're going to automate this process. There is a business in Australia that has made this robot which automatically lays bricks according to a blueprint. So I can feed in my plan and I can be very sure that the house is going to be built exactly the same way every single time. I know that I don't need to rely on some contractor to interpret that plan, to work out what the thickness of the walls should be, to make sure that it adheres to some kind of building code. I can make sure that that is all part of the automated tool that I'm using. Hopefully you get the analogy here. There are many reasons why teams might adopt infrastructure as code. I'm not going to go into these too much. I think a lot of people focus first on this idea of reducing manual toil, right? I want to automate something because I don't want to pay people to waste time to have to do that thing. But be aware there are a number of other advantages to this approach as well. Hopefully you're seeing some of these in your organization today. I think the other thing that helps with this is some examples. So our building robot here could be Terraform, could be Pulumi, could be CloudFormation, could be Ansible, could be Puppet. It could also be Kubernetes. I was really interested just watching Stephen talk about Kubernetes, and I was sort of thinking about someone who's fully in the Kubernetes world. And if you're in that world, you're probably so far down the path with infrastructure as code, this talk may not be for you, right? We're talking a little bit more about the messy world of a little bit of Kubernetes, but a lot of other stuff as well. So I just want to point that out. I also want to take a little bit of a detour because I've had a few conversations with teams who are on the journey with infrastructure as code. And sometimes they say, hey, teleport's not for us. We don't need an access tool, right? And when I ask them why, they paint this picture of a perfect world. In this perfect world, every single piece of infrastructure is managed via infrastructure as code. Also in this world, everything that you deploy is immutable. No changes should happen once the deployment has been made. If you want to make a change, you go through a code process. Eventually, the old thing gets torn down, the new thing gets brought up. Also in this world, you have centralized logging for everything. All of your application logs get sent to a single place, and that's where you look if something has gone wrong. Lastly, in this perfect world, no humans are involved in deployments. Everything is done via CI/CD pipelines. And there's nothing wrong with that ideal, right? There's nothing wrong with having that as a goal for your journey. But I've never really seen a team achieve this in real life, right? Reality is a little bit messier than this. And in a messy reality, centralized logs don't really capture everything, right? You might get your application logs, but you don't have operating system logs. You might have the wrong level of verbosity. You might not be getting the exact piece of information that you want. Some problems just require deeper investigation. Sometimes you need to jump into an environment, especially with a complex application, a distributed application. You might not really be sure if it's the network or something that's going on with the disk or something that's happening at the application layer, and you need to jump in and have a look. And the final thing that clouds this picture is the fact that pipelines don't really work in every single context. It might be a really nice aim to have for production systems, but pipelines may not be flexible enough for your dev environment, for your test environment, where you want your engineers to be able to innovate and try things really, really quickly. So for all these reasons, right, in an imperfect world, an access tool is still very, very relevant in your automated infrastructure environment, right? And I just want to point that out because I see some teams mention this. I don't think anyone in this room has this point of view, but you might run up against people in your organization who say, hey, we don't need an access tool, right? We're doing perfect infrastructure as code. It doesn't make sense. And I've never really seen that be true in reality. So if we think about the intersection of infrastructure as code and teleport, there are really two different ways that this could manifest. On the left-hand side, we have teleport for accessing infrastructure provisioned via infrastructure as code. On the right-hand side, we have the idea of bringing teleport configuration into your IAC process. Today's talk is very much about the left-hand side. I'm going to call that out up front. If you're interested in the right-hand side, I do have a reference slide. I'm very happy to talk about it. For me, the left-hand side is much more interesting. It's much more of a challenge to solve. So that's what we're really going to be talking about for the rest of today. And the first thing that I want to impart on you, if you exist in an environment where engineers have a lot of power, you've shifted left, people are self-servicing, they're not waiting for tickets, they're deploying things onto the cloud themselves. The first thing to realize with teleport is that agentless is your friend. Choose auto-discovery for the path of least resistance wherever you can. And I point this out because you may have realized at Teleport we like to release, and we like to release often. And in those releases we pack a lot of features, and often I talk to people who aren't aware of how much capability we have in this area. A lot of what's on the screen now was probably only added in the last couple of major versions. But this is the first place you should look when you're deciding, how do I integrate with Teleport? If you're running Linux on the major clouds, we have options for auto-discovery. Kubernetes on the major clouds, same thing. The major databases on AWS. We just added the ability to auto-discover applications within your Kubernetes clusters. So again, if I can impart one thing on you, please be aware of this list. Please try to keep on top of the abilities for auto-discovery, because it's going to be the easiest way to insert Teleport into a very dynamic environment. The other thing that I want to point out in this kind of theme of automatic access is we also have a part of the Teleport web UI which is very, very useful for someone that just wants to try it out. Right? If you've got one of these teams who says, I don't know if Teleport's for me, I don't know if that's going to work. And they don't want to put in the work to set up something like auto-discovery, which might need some credentials and a little bit of time. You can point them to the Teleport web UI, where we have a lot of guided wizards for adding your first resource. For example, if I want to add a Debian server into Teleport, the web UI can generate this single line of bash code, which I can run on my instance, and it's going to be joined in a few minutes. Very, very useful tool for pointing your engineers, your developers, your teams outside of your core team who just want to see what the workflow looks like. So, auto-discovery does not cover every single use case. There are so many combinations out there of applications, platforms, hosting environments. We would love to auto-discover them all, but we cannot. So if you cannot auto-discover, what do you do? This is where you would insert teleport into your infrastructure as code workflows. And when I think about what's involved there, there are really three kind of abstracted steps. Two of them are on the screen. You need to somehow get the teleport binary. You need to somehow provide configuration values for teleport to be able to run. And there's a third step, which we'll talk about in a second. And if I think about when I talk to teams where they do these things, there are three stages of the deployment lifecycle where I see this happen. You might do this pre-deploy. Okay, if you have an image building workflow, if you're using a tool like Packer or AWS AMI Builder, you could achieve these two things pre-deploy. This is really nice because before anyone has deployed anything onto the cloud, you've already inserted teleport into the process. You can have other steps at this stage, which maybe scan the image, look for vulnerabilities. You can do this on a schedule. You can do this every time that your software is updated. There's a nice life cycle you can have around image management. Very handy place to insert teleport. I also talk to teams who do this on deploy. Okay, a tool like Terraform or Pulumi or CloudFormation can achieve this as an instance is deployed using something like Cloud Init or user data. The third place then is post-deploy. So you might already have processes around configuration management, and once your instance is up, you could also add some code to add teleport into that process as well. Now I mentioned that there's a third thing, a third step here, which is about managing the teleport service. And I break this out because there is a very key dependency to this step, which deserves its own little section of time here, right? And this dependency comes back to the idea of trust domains. And if you've listened to any of the talks today, from Ev all the way down, a really core architectural tenet of teleport is the fact that we rely on identity domains, right? The main one being our certificate authority, but we also delegate to other trust domains as well. For user authentication, we can delegate to your identity provider. And this is really important for any kind of automated deployment of teleport because you also want to delegate to other trust domains wherever you can. And the easiest way to do that is if you are on one of the major cloud platforms because we support platform native identity for those services. So let's run through that really quickly. On AWS, this is IAM credentials or an EC2 identity document. On Google Cloud, a virtual machine with a service account or GKE workload identity. Azure managed identity, Kubernetes service accounts. So point number 2 that I want to impart on you is if you cannot auto-discover, find out where you can use platform native identity and use it anywhere you can because it's going to make all of your other automation steps much, much easier. Now you might be thinking, okay, that's great, but I can't use platform native identity everywhere. And that's absolutely true. And we're going to talk about what you can do in that case as well. But before I do that, I wanted to get down to the next level of detail and talk about an example of one of these workflows because it's going to make it a little bit more real. So here we have a GitHub repository. In this GitHub repository, I have an image building process defined. And there are 2 files in here. One is a Packer build file, which describes pulling down the teleport binary, setting up the systemd service, and templating a configuration file. And I've got that template as the second file in this repository. That template takes in 2 variables. One is the location of my teleport service, the address of the auth server, because this might change depending on my region or my environment. The second variable is the name of the IAM token that I'm using in my environment. So I would hook this up to Packer using some kind of CI/CD. Let's say it's GitHub Actions. Packer would be integrated with AWS to be able to publish an AMI each time I change the code in that repository. And here I can have my nice little independent life cycle around making sure that I'm publishing good images. I would then have a second repository which describes my actual infrastructure deployment. So here I've got some Terraform code which describes a self-hosted MongoDB database it's going to be using the teleport image that I built earlier. And it's also using user data. So remember earlier I pointed out kind of 3 different lifecycle deployment options: pre-deploy, on-deploy, post-deploy. Here I'm using both in concert, right? We're doing some very generic configuration pre-deploy, and then we're augmenting that configuration on deploy. And I'm telling my instance here that it should be running a database service and that it should be proxying for a Mongo database with a variable for the name and for the URI for that particular database service. So again, GitHub here can trigger a Terraform build when code is committed. Terraform will consume the AMI that I built earlier. It's going to build my infrastructure. Eventually I get an instance which can register to my teleport control plane using IAM credentials. Now the other pre-step here is that my little teleport control plane on the right-hand side has been pre-configured to trust particular IAM roles in particular AWS accounts, but that's a one-time operation. From then, anything is able to join as long as it presents the right credentials. Okay, so a very common workflow around image management and infrastructure management, all using infrastructure as code and relying on cloud native identity for my services. So back to that question, what if I don't have native identity? What can I do? And let's use the same example to explore this. Here we have a very similar looking repository, but there's one key difference here. If you look down in the teleport configuration template file, I'm now no longer naming an IAM token. I'm going to point teleport to a particular location on the file system where it should expect to find a token to join the cluster. Now it's pretty important here to point out that you don't want to hard code any kind of secret in your pipeline which will allow this service to join when it eventually boots. It is a bad idea. It really breaks any notion of a trust domain. You're moving into long-lived secrets. You're introducing a risk. It's something that we really want to avoid with teleport, so we're not going to do it. So in this example, we're going to use Packer to publish an ISO to vCenter. We're then also going to have our Terraform code, which describes the instance that we want to deploy. But there is now a new piece of Terraform code in here, token.tf. This is a resource that is going to interact with the teleport cluster itself before deploying the instance so that I can generate the join token that teleport is going to expect when it boots. So here I'm using my Terraform code to say I want a token that is valid for databases. It should be valid for an hour. And then the output of that token is consumed by the user data that's part of my instance deployment. Okay, so we're going to, whoa. Sorry, fast forward, man, there. We're going to generate the token. Teleport's going to consume the ISO just like before. It will build my vSphere virtual machine, and vSphere will register to teleport using the token. So this is nice, except that it's not nice, because I've kind of cheated in this example. And the cheat here is that Terraform was able to generate a join token from teleport kind of magically, right? It didn't have to authenticate to teleport. I'm kind of breaking my own rules that I've set up here that everything is about trust domains, everything is about identity. And I've let Terraform interact with teleport without an identity, which we absolutely should not be doing, right? So this is something that we need to fix. So how do we fix this? We extend the notion of a trust domain out to automation tooling as well. We do this via a feature called Machine ID. I think Noah spoke earlier today about this. Hopefully you saw it. Lots of great use cases for Machine ID. It's particularly relevant for this topic because it solves the problem that we have around the very first handshake between our automation pipeline and teleport. How do we establish that trust if we don't have the identity that we had in the cloud? So we can extend that trust out to GitHub Actions, GitLab CI, Circle CI. We can use tools to get more granular on what we actually trust within those platforms. And I've included Kubernetes service accounts here as well. We just very recently added the ability for Teleport to trust service accounts from multiple Kubernetes clusters. Previously, everything had to be in the same Kubernetes cluster. That is no longer the case. This really opens up the opportunities in terms of bootstrapping trust, because you might have some kind of automation platform which is not listed here, but I would bet that that platform supports workers within Kubernetes. If you have a worker in Kubernetes, it can have a service account. You can set up trust between the service account and Teleport and use that to bootstrap your pipeline. The other thing I want to point out here, that this is on top of the cloud identities that I spoke about earlier. So if you have a Jenkins deployment that maybe has workers that could sit within AWS, you could use that AWS identity to generate a join token for some service that eventually is going to be booting up on-prem for your on-prem Mongo deployment as well. Okay, so to recap, use auto discovery where you can, use native identity where you can, use pipeline identity where you can. And let's take a look at this in action. So our image build step is the same. On our infrastructure build step, we now have a new part of the process. There is a teleport process that is going to run first. When we trigger the infrastructure build, our teleport step is going to authenticate to the teleport control plane. It's going to present a JWT, which comes from the metadata available to the pipeline, and it will use that to generate a single-use teleport identity. Terraform can then assume that identity, use that to safely generate a token, and the rest of the build can happen safely. So to highlight this again, if I'm thinking about Teleport and my infrastructure as code strategy, how do I approach this? The first question I would always ask is, what does your stack look like? What are the supporting services for your applications? What infrastructure do you have, and how much of that do you want to bring into Teleport? What does your roadmap look like? Out of all of those things that you identify, I would work out how many of those could I auto-discover. For those that I can't auto-discover, how many can I use platform identity? And where can I use pipeline identity as well? If you've seen some of the examples that I've shown and you thought, okay, that's cool, but I want the next level of detail, or I want to try this out, you absolutely can. Please visit my GitHub. I've got a whole heap of examples of using Terraform with Teleport and other infrastructure as code tools as well. Everything that I've spoken about in this talk, there is code in there that you could download, copy, fork, modify, and use yourself. We also have a pretty good recently added page in our documentation about deploying agents and securely joining those to your cluster with Terraform. A whole heap of docs on machine ID and a lot of information on some of the native identity options that I spoke about earlier as well. With that, I want to thank you for your attention. Really appreciate it. I hope you enjoy the rest of the night.